Hi everyone. In this video we're going to go through section 10.2, the second part, which will be much shorter than the first part, and what we're going to cover is the p-value approach to a hypothesis test. I want to emphasize right off the bat that if you are asked about a p-value, this is a Minitab question, whether it's in my math lab, homework questions, or on your next test, or on your final exam. Anytime you're asked about p-value, I want you to jump right to Minitab and use that and click through and figure out, do the hypothesis test in Minitab, okay? In a homework question, you might be asked for other things too, like a test statistic, which isn't technically needed with the p-value approach, but you should still be doing that question in Minitab, okay? I'm not going to show you how to find a p-value by hand. It is possible, but the purpose of p-value is really to speed up the process because it is just clicking some buttons in Minitab. All right, so in the previous video, in the first part of the section, we saw that if we have our distribution, okay, and here's my ooh, that's terrible. Try that again. Here is a slightly better drawn distribution, but I'd say slightly. Let's say it's a right tail test, right? So we have this shaded area, this critical region on the right side of our distribution. If I get my test statistic from the sample data and it falls in that critical region, we reject the null hypothesis. And if it falls outside of that critical region, we do not reject the null hypothesis. Well, with a p-value approach, this is emphasizing the p stands for probability. If the probability of getting a sample proportion as extreme or more extreme than the one obtained is small, under the assumption of the null hypothesis, reject the null hypothesis. All right, so what that means is that if my test statistic, let's say that we have a alpha equals 0.05% level of significance. That represents the area of all that's shaded red over there, right? Let's say that my test statistic does fall somewhere over here inside of that red region. Okay, what that means about my test statistic, let's say it's, like 2.33 standard deviations above the mean or something like that. It means that my p-value would be less than 0.05. When I click through the menu in Minitab, and I'll have a video in Blackboard also to show you how to do this in Minitab, but when I click through the menu in Minitab, whatever the p-value spits out might be 0.02, 0.01, 0.005, but it would be less than 5%, and in that case, we would reject the null hypothesis. So here we have the slide with tons of information on it. I went through the left-hand side in the previous video, so let's kind of spotlight the right-hand side. First, I'll talk about what doesn't change, right? The approach to how we set up our test, that does not change, whether it's left, right, or two-tailed. The null and alternative hypotheses, we write them the same way. The level of significance alpha, that's still established by the question, the homework problem, or the researcher. Okay, but if I zip over here to the p-value approach, what is different? Now, in these steps, it does mention the test statistic. However, that is not needed to answer this question because we're using technology. Okay, that we don't need that because we're using technology. So Minitab replaces that step. Minitab replaces that step, and when I get through the menu in Minitab, it's going to spit out a p-value, can't write, equal to some number, and then we check down here, is my p-value bigger or smaller, oops, I didn't go low enough, is my p-value larger or smaller, well, there we go, than alpha? And if it's less than alpha, you reject the null hypothesis. Okay, so we don't need to do that by hand step 3. We're doing down here the technology step 3. Okay, we click through the buttons, we compare the p-value to alpha. It's much quicker. Okay, it's a little bit less intuitive. You're just looking at the numbers as opposed to like seeing where you are on the distribution. But if the p-value is less than alpha, reject the null, and then state your conclusion. Now we get to look back at the example about the ACT exam. I'm not going to go through this in its entirety again because hopefully you watched the previous video. But pointing out what's different, right? If we were doing this with the p-value approach, our step 1 would stay the same. Check that off. Our step 2 would stay the same. Our step 3, that would be different. That would be typing things, clicking some buttons in Minitab, M-I-N-I-T-A-B. There we go. And then let's say that Minitab spits out a p-value. Now, because we rejected this one, I know it's going to be small. Let's say Minitab says the p-value is 0.025. It's not that. If this were a regular class section, we would investigate this in Minitab ourselves. But because we're not in regular class right now, let's just pick a number. I know it would be smaller, but let's say it spits out 0.025. So because 0.025, the p-value, is less than 0.05, which that is, let me get my highlighter here, that is the alpha, the level of significance. We're bringing that down here, right there, because the p-value is less than alpha. It's our step 4. We reject the null hypothesis and state the same conclusion. Okay, that's the difference. It's a lot shorter. You just compare the two numbers, one of which is in the problem, one of which you get from Minitab. Okay, and then we get to the gun ownership example. Again, setup-wise, step 1 is identical. Step 2 is identical. Step 3 is obsolete, right? This is where we get our Minitab step. And then let's say in Minitab, okay, let me come down here. Step 3, Minitab. Let's say that spits out a p-value equal to 0.27, right? 0.27 is greater than 0.10. Therefore, we do not reject the null hypothesis. Okay, that's the difference. The same conclusion is drawn. One is a little bit more formula heavy. The other one approach is a little bit more formula heavy. The other approach is a little bit more button clicky. But again, it's less. You learn less about statistics doing the other approach because you're just looking at these two numbers. Which one's bigger? Which one's smaller? Hopefully you get the idea by now. I just want to briefly talk about this last one. If you remember from the previous video, we got a z-score that was really, really high, 5.12 standard deviations above the mean. What that would correspond to in terms of the p-value, V-A-L, there we go. It would be super, super small. It would be 0.001 maybe, and sometimes Minitab even has some z-scores so extreme that the p-value, it might just spit out 0.000 sometimes. That just means that this is super duper unlikely. The probability is so low, we can only print 0 because our rounding error is only so accurate, okay? You would still draw the same conclusion, reject the null hypothesis, but like you can have an extremely low p-value. And remember, p-value, you're just thinking probability, low p-value, low probability, reject the null hypothesis. All right, that's it for this video. Thank you for listening. Know that on a test, I will be extremely specific whether I want to see a test statistic or whether I want you to use Minitab and compute and find a p-value. On the homework, they walk you through how they want to walk you through. On a test, I will make sure that you know what approach I want to see. All right. Thank you for listening. Make sure you're working on your homework. Let me know if you have questions, and make sure, please, that you do view the YouTube video on how to do a hypothesis test in Minitab. Thank you for listening.